Okay, I'm still continuing the series here. In part, it's a continuation of a tribute to Matthaus, Merian, the Elder, and this type of geometry which I've been exploring. And I found a few more things that have to that are essentially derived from these foundational geometry symbols: circle, square, triangle. And I'm starting with this configuration here, which is quite familiar to most of us, where it's often seen in textile patterns and stuff like that, where you just have these types of arrangements here. Usually, I did not fill the rest of that out, but you can kind of see where that familiarity of that type of a pattern. And essentially that pattern, which is quite common in a way, this is how that pattern is derived from a square and then drawing circles around the square. And what I did was I then drew in the smaller circles, right where the circles around the squares all touch the circumference of the smaller circles. And this turned out to be interesting because there's actually a geometry which can lead to something just from the simplicity of this type of a pattern. And what I found was just keeping that last one in mind, where you have the smaller circle and the larger circle around the square. So I started this one with that foundational geometry kind of arrangement, a triangle, square, and the circle. And what I found was similar to this, right, where the smaller circle is in the middle. This one here, you'll see that the smaller circle, which is the same size, because these are the same size square kind of thing, which fits inside the triangle. So then I thought of moving the triangle so that the circle falls in the middle of that square. And when I found that, I realized, after some, exploring here, that we're along the horizontal axis, where those two circles meet, that point there, that distance from where those two meet to where otherwise the tip of that triangle would be, right there. So from where those two circles meet, the smaller circle and the larger circle on that horizontal axis, that measurement between the tip of where that triangle would otherwise normally be, that distance there, and when you take that distance with your compass and or your divider, you take it to that point up there, and then when you make that arc, it'll cross the 2 points of the side of the triangle right there. And when you join that line and you fill out the rest, the way I've explained how to find a square inside a triangle, it gives you a way to get another way to give you another way to find a square inside the triangle. So I found that really interesting. This is just kind of my symbol I've kind of come up for for a compass and or a divider. And okay, so if you follow that logic, essentially this led me to finding this. And then I found another way to find a square inside the triangle. Okay. And the next one is the same thing. It's just I did a bigger version just to check the accuracy and make sure that this method still works. Sometimes, and there's things I've done in the past where I have not, checked to see that they work in larger scales as well. But this one I did. Same thing. Your foundational geometry symbols, and I moved it from the bottom. The middle circle, moved it from the bottom to the middle. And in the same way, from that distance where the two circles meet to the tip of where that other triangle normally would be, that distance, and using that same distance from the top, from the apex, and scribing it, that'll give you the 2 points for the top of that square. And the rest you can find out, fill out. I've showed you how to do that before in my last video, I believe. So this was essentially a kind of I'm just checking to see if this method still works in a larger scale. And it does. Okay. And then I went back to this similar arrangement, and I started to work out where the different squares that I could find for the different triangles. For the 40, which I showed before, for the 60 degree, and essentially I was just going through this step again, using that same principle with the larger circle around the square and the one in the smaller circle that fits on the inside. And where those 2 points meet, this distance here, right from the sides, ends up being quite significant, is really what this is about. And the other information there is just, this was the steps I went through, and I just made some notes as a reminder to myself how I did things. Okay. Then I tried a similar thing, and I included the other triangles in here. And what I found in this one was that distance where the larger circle around this imaginary square here meets the smaller circle is this point right here. And I ended just using this vertical on the two sides of where that otherwise where that smaller circle would fit inside that triangle, right? Because, just going back one step, you will see that when you move that triangle and its inside circle, right, which is the same size as the from this format. So when you move this and you get that circle into the middle, the triangle, instead of resting on the bottom, moves up, and the tip breaks through the top of that square. Okay, so that's what I've included here. But going back to the important part here is when I drew those lines in on the two vertical axes of where that larger circle and the smaller circle meet, right at those points, and I extended the vertical all the way up, I found something else. When I connected a line from the top of one of those verticals to one of the corners, that corner to the top, I found a 51.42 angle on each corner. So that's really interesting. That's the next thing I found. And let me see, was there something else here? No, yeah, I'll just share what I thought was significant here. And then I continued this process after finding out that last bit of information. This time I just did triangles. All the triangles. I left the circles and the other squares out. I just wanted to see what this would look like with just the triangles. Okay, and of course connecting the last one that I found from the corner to the top of those verticals, which essentially they remind me of these two pillars. Right, these are like two pillars, and there's your apex kind of on the roof, like your Parthenon or your Pantheon kind of thing. This is like a geometrical kind of similarity to that kind of visual, and so I liked the look of this, so I just made these. They're, to me, they're kind of like two pillars here, and it holds up and of course all these angles, and these triangles and so forth. They do end up producing something quite unique here. Especially with the last one I found, where I found a 51.42, and how that extends all the way to the top of those pillars from the corners. Okay. That's where I got to on my next step. And then I decided to start using stuff selectively. And interestingly is when you go from the bottom middle and you draw a diagonal to the top corners, interestingly, that line seems to go through the corner of each one of those squares. The square that fits inside the 51.42, or from the top it's a 77.14. The corner within the 60, that line seems to go right through there, and that diagonal seems to go right through, or very close to it. Sometimes you got to fine-tune that. It might not be exact, but it seems to be very close to the same point of where that square fits inside the 40-degree angle, the center green one, right, which I covered in the American dollar bill symbol. So I found that very interesting. Just kind of hold it there for a second, give you a better look, and then I got to where I wanted to use the minimal amount of all that other information that I found. Just something which is more understandable. When you have too much stuff in there, it's so busy that, somebody can't really understand what's going on. So this one, I've just included what I thought was like the more important type of information, the stuff that I have found, right? And when I got looking at this, it reminds me of a kind of a medieval kind of a church as well, with this, with this kind of a shape. If you can kind of see that part there without the outsides. And of course, at the same time, it still has this something similar to these two pillars. And there's a kind of a Pantheon kind of a roof over it. And so I decided to call this, in my mind, it was like, there's a name for this, I think. And I decided to call this kind of like a geometrical altar, right? It has this kind of an altar feel to it, and stuff like that. So yeah, just interesting stuff. That's the latest addition to my findings here. And if you've been following this series, you might find this interesting. And yeah, I'll leave it there. I think I said everything I wanted to.